In solar radiation, we studied how we measure incoming radiation, diffuser radiation, net radiation, and what is the percentage of the radiation is useful for the photosynthesis. Also, we studied yesterday, and then after that, we went through the different instruments which are used for the to measure the solar radiation, and then we studied the temperature. In the temperature term, we used what is a process for heat transfer, like conduction, convection, and the radiation process, and what is the basic differences, and what is the mechanism of heat transfer we studied. Then coming to the air temperature, like in that air temperature also we studied diurnal variation or horizontal variations or seasonal variations, how it occurs in the atmosphere. Then we studied the temperature gradient, lapse rate, adiabatic lapse rate, inversion, thermal inversion, and soil temperature. Like these topics yesterday we studied. So from this topic, so some important bits also there, like what is adiabatic lapse rate, the rate of the like what is the units, what are like the rate of change of the temperature per kilometer is how much in adiabatic lapse rate or lapse rate. These are two important bits. And what is the implications of the thermal inversion in environment, and especially in the national capital Delhi, and that is fog formation will be occurs, like smog will be occurs, and what is a radiation is reaching the earth surface out of solar radiation is also one of the important bit. And that is one more bit is also there from solar radiation. This how much of fraction of photosynthetically active radiation in different types of radiation, that is diffuser radiation or a direct radiation or a global radiation. So these are the some of the important bits. And what is a solar constant and its values in the different calories or well as in the watts also. In some years they ask these questions. And what are the instruments can be used for measuring the photosynthetic active radiation or incoming radiation or total radiation. So this instruments also important because they are asking in the multiple choice questions. So and so these are the some of the important bits. So that we discussed yesterday. And one more important topic is soil thermal conductivity and how it is varies with the water content and the moisture of the soil, and porosity or organic or matter, and how what is the relationship between them also important. And what is the variation of soil temperature in the soil, like diurnal variation is up to distance of 3 feet, that is 80 to 90 centimeters in the soil surface. That variation will be there. And we can expect some questions also very silly like that. The conversion from centigrade to Fahrenheit to Kelvin are also important. So like this we can. Yesterday we studied this type of the topic. So till now, like in these topics, anyone have any doubt? Anyone, like from the first year students, if you have any doubts, if you are not understood any concept, you can ask from the yesterday's class. If you are understood everything, we can go into the today's topic, that is atmospheric pressure, as well as it's like our further chapters we can discuss. So everyone understood everything. Like if you're having any doubts, you can ask now related to any basic differences or any topic what I told you now. So everyone understood. Can you talk people? Someone talk.
సార్ సార్
Speak up. Hmm.
సార్ మ్యాథ్స్ క్లాస్ అక్కడ జరుగుతుంది సార్.
ఎక్కడ?
సార్ 4:50కి మేము జాయిన్ అయ్యాను సార్ మ్యాథ్స్ క్లాస్కి. ఇంకా జరుగుతుంది
Okay.
సార్.
So what to do now?
సార్
ఏం చేయాలి?
సార్ ఆ క్లాస్ లీవ్ అయ్యాము.
ఓకే, లీవ్ అయినా కరెక్టే. నేనేం అడుగుతున్నానంటే ఇప్పుడు నీకు ప్రాబ్లమ్స్ ఏమైనా ఇంకా అర్థం కాని టాపిక్ ఏమైనా ఉందా అని అడుగుతున్నాను. నేను అడగట్లేదు క్లాస్ ఎందుకు రావట్లేదు అది నేను అడగట్లేదు. నిన్న చెప్పిన క్లాస్ లో కానీ ఇంకేమైనా నిన్న డౌట్స్ ఏమైనా ఉన్నాయా లేకపోతే ఏమైనా ప్రాబ్లమ్స్ ఉన్నాయా అని అడుగుతున్నాను.
నో సార్, నో సార్, నో సార్.
సో మీకు అన్ని అర్థమైనాయి అంటారు నేను అవుతుందంట. So today we will discuss about the what is atmospheric pressure. Atmospheric pressure is an important weather element in which, like, is an important weather element.
Yes,
It is.
yes. 1 minute, Vikram.
Mm,
That is you as per up to you. If you have math class or whatever it is voluntary. You may go. Don't disturb during the class.
Okay, right. There is a voluntary. If you are anyone interested, they can go to the math class, or else who are interested to listen these agronomy classes, they can stay here and listen the classes. Okay, there is a completely voluntary as told by the sir. So right now we are discussing about today's topic. That is one of the weather element which is not in the consideration for the plant growth, but is a consideration for the different weather parameter interactions. That is nothing but atmospheric pressure. Like this atmospheric pressure is not having any effect on the crop. So for example, if increasing atmospheric pressure, decreasing, it is no effect on the weather growth, like plant growth, but it's having interaction effect with the other elements like temperature as well as rainfall and wind movement. Such effects will be there with help of the atmospheric pressure. So it is an indirect effect of the weather element on the crop growth. So first of all, what is the atmospheric? Like the pressure exerted by the atmosphere on the Earth's surface is known as the atmospheric pressure. Like if people are known about the what is the pressure? Pressure is something is exerting the force on the some area that is known as the pressure. So if there's this force is applying on the atmospheric air, so this is known as the atmospheric pressure. So what are the units for the atmospheric pressure is generally we will use the Pascal. 1 Pascal equal to how many millibars and how many centimeters of the mercury. And like how we will measure the pressure is manometer we will use, and what are the chemical we will use that is a mercury. Like one atmospheric pressure equal to 76 centimeters of 76 mm of Hg or centimeters of Hg. That's a mercury. And if you convert it into the millibar, it will be 1013 is a millibars equivalent to 1 Pascal, or like 1 atmospheric bar, and 10 to the power of 6 dynes per the meter square. Like that, different conversions is there for in the atmosphere. We have to know that all the conversions and how will you measure the atmospheric pressure. There is a way with help of the Android barometer we can measure the uh, air pressure, like atmospheric pressure of the certain locations you can calculate, and this is consist of a cylindrical chamber. In it, the air will be exerted, some pressure on the air, like this is known as the atmospheric pressure. And what is the relation between the atmospheric pressure, where and as well as the air temperature? If in very areas the high temperature is there, automatically the air pressure will be low. Means air pressure is low means the air in the atmosphere will be get heated and it will go to the higher area. So there is a there is a difference in the air pressure. So what happens if air pressure is low? The movement of the wind from higher pressure area to the lower area pressure. Like this, the atmospheric pressure is having the relation with the other weather parameters like temperature and rainfall and humidity. So these are some of the interaction effects. And one more meter, like as I told, we have generally this atmospheric pressure is measured in the Emerald barometer. And nowadays we have one more meter, that is one more instrument is called barograph. Is a barograph is nothing but it is a recording type of the, like it will make an graph over a period of the time. Let's say 24-hour cycle, it will make the cylindrical graph. Like it, for example, it will be like 24 hours will be on the x-axis and the y-axis is head pressure is recorded. So it will make different graph like ECG graph. So based on that one, so entire for 24 hours, how much is the air pressure in the atmosphere, you can calculate. And with the help of this air pressure, you can get to know and when wind will come, when rainfall is coming, when like we can expect the weather parameters. So, and this barograph will rotates in a clockwise mechanism, and this atmospheric pressure is expressed in terms of millibars. So, what is one atmosphere equal to how many millibars? Anyone can tell. Like as I told, one atmospheric pressure equal to how many millibars? How many millibars? Harika?
1000, sir.
Not 1000, that is 1013 millibars equal into 1 atmosphere. Okay, so you write it down on a paper that you people can write it down these values because it's having more importance in your classes and it is a basic information. So 1 atmosphere equal to 1013 millibars or 76 centimeters of Hg mercury column, 10 to the power of 6 dynes per meter square. Okay, these are the three important conversions. And how we will measure the atmospheric pressure? Which instrument we will use? So just list out the any name of the instrument to use for the measuring of the atmospheric pressure. Which instrument we will use for the, anyone can tell. If I already told several times, so you people can tell what is the which instrument we can use for the measuring of atmospheric pressure generally. That is another barometer as well as the uh, barograph we can use for the measuring of the atmospheric pressure. And one bit is already told, this parameter is not having any effect on the crop, but is having effect on the indirect effect on the crop growth, will help for the other weather elements like temperature and the rainfall and the clouds movement and everything is related with the this weather element, weather parameter. So then coming to the next topic, that is wind. Wind. What is wind? Meaning is wind in what is the meaning of wind in Telugu?
Vegam.
Hmm?
Gali vegam.
Not Gali Vegam, that is Gali Vegam means that is a wind velocity. So wind is Pavanam. Any Pavanam. Like Pavanam means like Gali, like the same meaning. So wind means the horizontal motion of the air from higher pressure zone to the lower pressure zone. That is a wind, is a simple definition. Wind is a horizontal motion of the air from higher air pressure to the lower air pressure is known as the wind. So due to why it is moving from wind, why it is wind is moving, because of the difference in the air pressure. Like one area is having low pressure and one area is having high pressure. How this air low pressure and high pressure is created? Because of the solar radiation and the temperature is increases in the atmosphere. So the here the air in the atmosphere will be heated up and the hot air will go to the above like higher heights. So automatically there will be the air gap will be there. That air space will be created. So in that the low air pressure will be there. So automatically uh, from higher air pressure toward this moves towards the lower air pressure. So this is a real like mechanism behind the wind movement. So wind movement we already know that's one of the most important and uh, this and the wind direction is very important for the weather forecasting. Like if you see any agrometeorological weather stations, you will have the wind vane and the wind direction. Like there's a wind vane direction will be there at the top of the 3 meters of height from the earth surface. So it will show the wind is directing which side. So this weather direction is having important prominent role in the weather forecasting. So if you know the weather direction, like wind velocity direction, so you can inform the people that to go to agriculture operations and to make some arrangements. Like for example, if any cyclone is forecasted and it which speed and it which direction is moving, so we can forecast the people and we can alert the people for the their upliftment or their movement in from the danger zones. Like in especially in the coastal areas, you can see like in the rainfall season, that is a monsoonal rains, like cyclones will be alerted. Then they can tell that this much of the speed is coming towards the Bay of Bengal and towards it's moving towards Odisha and it's moving towards West Bengal. And like nowadays also they are giving like in the recent days they are giving about yes, right, yes, cyclone is in the West Bengal and Odisha is going to be affected. So they will tell us wind speed and how they will calculate wind speed is anemometer they will use to calculate the wind speed anemometer. So it will tell the what is a kilometer per hour speed, at what speed the wind is moving from certain location to another location. So they will measure the wind velocity and the wind direction. So with the help of this wind direction and wind velocity, we can uh, like give the disaster management precautions we can take and we can alert the people in that area. And And like I'll ask one question: the wind movement will be where will be higher, in the lower region, in the lower surface or upper surface? Wind speed is more in the lower or upper? Wind speed will be lower or upper? In which region the wind speed will be maximum? Like where you feel in the higher, like higher rise buildings or lower rise buildings? So wind speed will be lower in the ground, like near to the ground surface. The wind speed will be less. But in the higher regions, the wind speed will be high because in the wind in the lower region, what happens? The obstructions will be there, buildings and the trees or high-rise buildings will be there. So the wind movement will be like it will be stops and it will be reduced. So the wind speed will be reduced. So in the ground level, the wind velocity is lower when compared to the higher elevations. Okay, this is uh, the important. And one more is that wind velocity is higher during the daytime. The daytime, the wind velocity will be more than the nighttime. But generally, what we will feel is in the nighttime, wind velocity will be lower, and we will feel like in night we are getting good wind velocity. But it's a wrong perception because in the daytime, the heat will be generated. The solar radiation will heat up the atmosphere, and it will increases the wind speed in the daytime. But in the nighttime, no such mechanism will be there, so automatically wind speed will be lower in the nighttime. So the wind speed will be more in the daytime when compared to the nighttime. And how you look calculate the wind velocity is anemometer we will use, and then this anemometer how it will works is the this is having some uh, structure, that is it will have a 3 to 4 cups, like semi-spherical cups will be there, and they fixed into the vertical shaft, and with help of the wind velocity it will moves and it will generate the RPM, rotations per minute. It will generally it will give. So based on that conversion, rotations per minute, and they will convert into the wind velocity. So with the help of the anemometer we can know that. And what is the wind speed, like how at what speed wind is moving from one place to another place, from like a coastal area to the uh, land area, how it is moving and what speed is moving and which direction is moving. And so this is important. And so here we have the two types, windward side and leeward side. From wind is coming from the which side is known as is a windward side, and the wind is going from the which side is known as like towards is leeward side, from is windward side. So that is a two terminologies. Like for coming from which side, from is windward side, towards is leeward side, and these winds having a greater impact on the weather forecasting. For because these winds will brings the rainfall and it will brings the like air pressure balance. So automatically that rainfall occurrence will be there with the help of the winds, and there is a greater damage of the winds. Like we can see in the tornadoes and these hurricanes will be there, and they having a huge impact on the people. So there is a wind. So till now we discussed the two parameters, that is we discussed two parameters, that is atmospheric pressure as well as the wind. So till now having any doubt? Any doubt? Till now if you are any doubt, if you are having no doubt we can go for the next heading. So anyone can tell if having any doubt? No. Understanding or any problem like voice clarity, or can I go slow for explanation, or this speed is okay? If you are in fearing talk, you can message in the chat box. So it will be good. You can inform me if you are having any problems. Like I will take your messages in the chat box, so it will be help for me to coordinate easily. So then next topic we are going to discuss is humidity. Humidity is nothing but the what is the content of water vapor in the atmosphere. Like what is a water vapor? Like that is known as the humidity. Because how this water vapor is generated in the atmosphere is the process of the evaporation. The water is evaporated from the soil surface to the atmosphere. So this liquid will be suspended in the atmosphere. So this is known as the relative humidity. And the water vapor is nothing but the colorless and odorless and tasteless and consists of the minute droplets of water suspended in the air. So this is the water vapor. So this water vapor contained in the atmosphere is known as the humidity. And it is depend what is the amount of the water vapor present in atmosphere depends upon the wind and temperature. For example, wind is moving from higher pressure to lower area. The water pressure also moves from one water vapor also moves from one place to another place, and water vapor will be evaporated with the help of the wind. So in the similar with the temperature, if the temperature will be lower, the water vapor content in the atmosphere will be more. So like that's why you will get a foggy condition in the winter season, that too in the early mornings. So when the temperature rises in the atmosphere from morning to afternoon, the water vapor present in the atmosphere will be disappears and it will be evaporated and your visibility will be increases. So this is a humidity content in the like you will feel these are the humidity related to the stuff. So the relative humidity will be more in the mornings and the evenings, but in the daytime the humidity levels will be reduced because of the evaporation of the water vapor from the atmosphere. And we have the two terms related to the water this humidity, that is absolute humidity and the specific humidity. Absolute is nothing but weight per the value, like how much amount of the water is present in a 1 meter cube of the atmosphere. It is known as the absolute. Absolute is means 100%. Like this is a exact word. So that is the weight of the water vapor divided by the volume of the air. That is gram per centimeter cube or centimeter cube is known as the absolute humidity. And what is specific is like weight on weight, like water weight of the water vapor divided by weight of the air, including the water vapor. So like this is known as the specific means any specific means unit by unit is known as the specific, and a unit by any value is known as the absolute. So these are two terms, absolute humidity and the specific humidity. So what is the formula for absolute humidity is, that is amount of the water vapor present in a unit quantity of the volume of air is known as the absolute humidity. Then what is specific humidity is the weight of the water vapor per unit amount of weight of the air, including the water vapor, is known as the specific humidity. So people should know about these two definitions and how they are calculating. If you don't know, like some people in the examination paper setters, they may ask very simple questions, and if they are asked what is specific humidity and absolute humidity, so we will confuse. So what is absolute means gram per meter cube, that is absolute. What is specific is gram per gram or kg per kg, that is gram per kg, that is known as specific. And then coming to the crop growth point of view, this absolute humidity and specific humidity not having any effect, but the having effect is relative humidity. So what is relative humidity is what is the amount of water vapor is required to become saturation. Means for example, in atmosphere around 80% of water vapor is there, so remaining 20% is required to become the saturation. So this is known as the relative humidity. For example, in atmosphere it is having 80 percentage and its water vapor required for saturation is 100. So into 100, it is known as the relative. So the relative humidity is formula is water vapor present in the air. For example, that will be 40, and water vapor required for the saturation is maybe 100 into 100. So it will be 40. So the relative humidity is 40 percentage. So based on that one, so what is the gap between the water vapor present in the atmosphere to the saturation level? So saturation means entirely the air is filled with the air droplets, that is water vapor droplets. So that is saturation level. Saturation means 100% is filled with the air droplets in a volume of the air. Like it is completely filled with the water vapor in the volume of the certain volume of the air. So that is saturation. So what is the difference between the saturation and saturation of the air pressure, and what is the water pressure at the exact time? So this is a difference is known as the relative humidity. So what is the remaining part to be filled is relative humidity. So this relative humidity is highest, like it is having the good interaction on the weather growth, like in the crop growth, because if it is evaporation, for example, weather is having the high relative humidity, so the evaporation will be less. For example, if it is having 90% of the relative humidity, so the evaporation from the soil surface will be 10% only. If it is your relative humidity is 40, so that's remaining 60% of the water vapor should be evaporated from the soil surfaces. So the soil will be evaporated, means the plant can't absorb the water from the soil surfaces. So this relative humidity is having good impact, and it's having a significant role in the plant growth as well as. And if your relative humidity is more than 80 to 90%, 90 percentage, so it is having the pest also, like it will congenial for the pest growth. So these are the impacts of relative humidity on the crop growth as well as the pest. And so till now here people are having any doubt. So what is the relative humidity of the any area? That is around 80 to 90%. And based on this relative humidity, the rates of evaporation and the transpiration uh, will be occurred. Like for example, relative humidity will be lower, so the more amount of the transpiration and evaporation will be taken place in the atmosphere. If it is the higher will be in the relative humidity, so automatically the lower evaporation and transpiration will be taken place through the soil as well as the plant surfaces. So that is a very significant. And what is a weather pressure deficit? Weather pressure deficit is nothing but it is a difference between the saturation vapor pressure to the actual vapor pressure. So there is a difference. This is a vapor pressure deficit. If it is more than 2.5 kilopascal, it is known as a dry air. Means that this gap is more, means the air in that air in the air the suspended water pressure is less. Water vapors are very less. So that's why the air is known to be called as a dry air. If it is that difference between the saturation vapor pressure and actual vapor pressure is less than 1.5 kilopascals, that air known to be as a wet, like humid air, because that difference is very lower. So the presence of the water vapor in the atmosphere is more. So automatically that will be humid air or a wet air. So that is a difference between wet air as well as the dry air according to the difference of the vapor pressure deficit. So the vapor pressure is also over. So how we will measure is we will have the different instruments like psychrometer and hygrometers or Stevenson screen. The psychrometers consist of the wet air bulb thermometer and dry air bulb thermometer. So with the help of those things, you can measure the amount of the relative humidity. So here what happens is we will have the wet bulb thermometer and dry bulb thermometer. So dry bulb thermometer is a actual, it will measure the what is a how like what is a amount of the air is transpired from the certain location. Like it will give the exact temperature of the location, and wet air means the amount of the water is evaporated from the atmosphere. So here the wet air bulb thermometer consists of a cloth, and it will be dipped in the any water container. So because of the temperature increase in the temperature in the atmosphere, the water molecules are evaporated from the cloth. So this is the amount of the water is evaporated, and remaining was dry bulb. So the wet minus dry, it will give the vapor pressure deficit. Based on that, you can calculate the amount of the relative humidity in the atmosphere. So this is one instrument we will use for psychrometer, and here we will have the Stevenson screen also is having the two types of the thermometer, that is a wet bulb and dry bulb, and the maximum minimum temperature. So those will be arranged in a horizontal and vertical manner. And here in psychrometer we will arrange the exhaust fans inbuilt that will set the entire in the air pressure, and it will avoid the saturation levels in the box. So and one more instrument is also there, that is hair hygrometer, which we use to measure the relative humidity in the inside the rooms. It is the what there is in that instrument, we will generally use the human air as an indicator. If it is expand, the moisture is, if the moisture will be there, it will absorb and it will expand. So means it is a wet in conditions. If it is done, the hair is contracted, then it will be dried air. So that is there is a more relative humidity, like the density is more. For example, if it is expands or it will absorbs, it will be expands. The hair will be expands. So then it will be known as a humid condition or wet condition. If it is dries, that will be the hair will be contracts. So this the expansion and the contraction will be pointed to the meter, and based on that gradual scales, so we can measure the relative humidity of the area. And one more meter like thermograph or barograph. Here we have one more instrument, that is a hygrograph. It is also gives the 24 hours the relative humidity in the atmosphere, and x-axis on the x-axis on the time, that is a 24 hours, and the y-axis on the relative humidity. So it will give the values continuously, and you can use these values for the weather forecasting for a long term basis or short terms also. Like it will be very useful. So till now, if people having any doubt, so till now, if people are having any doubt, can ask. If you are having any doubts, ask me now. No doubts. So I will ask one question. Okay, what is a unit for specific humidity? Anyone can tell in the chat box, or they can tell directly through mic. What is the units of specific humidity and what is the units of relative humidity? What is the units of relative humidity? Size station? What are the
percentage, sir.
percentage and how you will measure the absolute humidity? Absolute humidity. Which instrument we will use for the which instrument we will use for the relative humidity calculations? Anyone?
Hygrometer, sir.
Hygrometer or psychrometer. The both instruments can be used. And what is the height of the Stevenson screen meter from the Earth surface? At what height we have to install the Stevenson screen? At what height? Which height we will install this Stevenson screen? Options 2 meter, 3 meter, 1.22 meter, 1.55 meters. Out of which one will be correct? That is 1.22 meters. So people are listening or not? No one is answering me. Okay, till now we discussed about atmospheric pressure, humidity, and the wind. So now we will discuss the evaporation. Like that is a one more weather parameter and how it will affect. So evaporation. What is evaporation? Evaporation is process by which the water in the liquid state will be converted into the vapor and which escapes into the air. That is nothing but the conversion of the water from the earth surface to vapor into the atmosphere. It is known as the evaporations. So why its evaporation is very more important in the agriculture? Because based on the weather uh, evaporation from the earth surface, you can measure the amount of the irrigation can be supplied to the crop. So that evaporation is most important from the plant growth point of view. So we have to measure the evaporation levels in the earth surfaces. In that, which type of the instruments we will use for the evaporation? That is, we will use USPV open pan evaporameter and sunken screen evaporators and can evaporators. So which one will be more accurate in the evaporation calculations? Anyone can know? Anyone knows which instrument is very effective for calculating the evaporation levels? That is USWP, USWP open pan evaporameter. It is like United States Water Balance and Weather Bureau. They developed this evaporameter. So with the help of evaporators, you can measure the amount of the water is evaporated into the atmosphere. So because if you know the evaporation levels, you can give the amount of irrigation, and you can know the what is the water loss from the soil surface and how you can conserve it, and we can plan our crop management practices. So for that reason, this evaporation is very more important. If your evaporation is more than your precipitation levels, you can like give some any supplemental irrigation, or you can provide any uh, stress related chemicals to the crops. So that's why this evaporation is more important in the crop management, not in the weather management. It is important in the crop management point of view. So here, the US double peak pan evaporameter is open pan evaporameter consists of the 120 diameters of cylindrical structure and with a height of the 25 centimeters. So that will be covered with the mesh because that water should not be taken away by the any birds or any animals present in the cropland. So they should not be taken out. So because if they will drink it as a water, so our observations will be spoiled. So we have to use the mesh to cover it with the to cover the that evaporator. So what the here we have to know what is the diameter of the evaporator and what is the height of the cylindrical height of the evaporator. So that is the height of the cylindrical weather evaporator is 25 centimeters and the diameter is 122 centimeters. So that is this measurements also important because this is given by the Interstate Weather Bureau. So this measurements is very important. Here we what we will see is we will have the inside one scale will be there. So here we will fill the water in the everyday morning and next like by evening we will measure the what is amount of water will be evaporated. So here the levels of evaporation will be uh, measured in the per day, like how much of the like millimeters of water will be evaporated into the atmosphere per day. So here in this way these calculations will be taken place. And one more weather emergency is like a sunken stone, sunken screen evaporameter will be there. Here this is also similar kind of the US double beam meter, but here we have the two cylindrical, that is uh, at 45 centimeter, like two cylindricals will be there. That is a 60 centimeter diameter. One more is 15 centimeter diameter. So in the height of the this evaporator is around 45 centimeters. So here we have the two cylindricals. Both are connected by the one more is a cylindrical structure. It will be converted. It is like one is a lower diameter vessel and one is a higher diameter. So in the both we will have the water will be there. Like we will fill the water. So in that like this will be there. So here we will bury the out of 30 centimeters will be buried in the soil. So that it will be buried in the soil. So in that amount of the water is how much is transpired. We can know from the 15 centimeters visual. So in that way, so we will measure the level of evaporation from the surfaces we can measure. And one more is like a can hygrometer. It is a simple instrument. In the we will use 1 liter can or iron tin. Is painted with the white and the marker is fixed above the 2 centimeters below the knob. So until that we will fix the water and the amount of the water will be evaporated. From that we will measure the how much of water is evaporated from the so can hygrometer. In this way we will measure the evaporation from the as a can. The can is like very simple one that we can use in the ET, but it won't give the any exact like in the professional way. It can't give the exact amount of the evaporation levels. We can know that is a rough estimates. It will give the evaporation level, but if you want exact amount of the evaporation levels, you can use the ESWB pan hygrometer. That is generally in the observatories of big type of the observatories, we will use the ESWB, not like can hygrometer, sunken evaporator. So these are the different instruments we will use for the measurement of the evaporations. So till now, if people having any doubts, who given the USWB open pan evaporator? Who given? Who developed the USWB open pan evaporator? And that dimensions also very important. That is 122 centimeters of diameter of the frame and cylindrical, and the height of the cylinder is also important. And coming to the sunken, as I told, here we will have the two vessels, that is a 60 centimeter diameter as well as the 15 centimeter diameters of the vessel. The both will be connected by the cylindrical, and the height of the this sunken barometer is 45 centimeters. So out of the three fourths will be buried in the soil. Means in 45 centimeters into three-fourths means roughly around 12 centimeters or 11 centimeters will be above the surface, and the remaining will be under the soil. It will be filled. Then 30 centimeters in the inside the soil and remaining 15 centimeters will be above the surface. So you can know the level of evaporation from the small cylindrical structure, that is a 15 centimeter vessel. You can get to know how much is evaporated. That will be having the hook gauge. With help of the hook gauge, you can measure the amount of the water is evaporated from the soil surface, like from the atmosphere, like it is from the soil surface. Then one more is simple instrument, that is a can hygrometer, that is a 1 liter capacity, and we will use the 2 centimeter marker below the mouth of the bottle. So from that we can measure. That is a rough estimates of the whether um, evaporation can be measured. So in this way we can measure the evaporation. So now we have the another weather element, that is a rainfall. So rainfall is like we already know rainfall is nothing but it's a falling of rain droplets into the atmosphere. But here we will use another word called precipitation as a rainfall. As a synonymously, we will use another word, that is rainfall. And what is the size of the raindrops? Any estimate? Like anyone can guess what is the size of the rain droplet?
0.2 mm, sir.
0.2 mm. Okay, but it's okay, not exactly, but it will be in international standards. The diameter of the raindrops is more than zero point 0.5 mm. Is known as the raindrops. 0.5 mm above the, that is known as the raindrop. If this is a below that one, we have the different names. That is like almost it will be fog, like that will be there. The droplet size will be less, but generally if you want to call it as a rainfall, it should be more than 0.5 mm to maximum up to 4 mm in diameter. Here we have the different rainfalls. Like anyone knows about different types of rainfall? Can name anyone like a drizzle, sleet, what is snow, what is hail, what is mist, what is fog rain, what is rain. Like rainfall is the diameter of the rainfall droplet is more than 0.5 mm. It is known as the rainfall. But if it is the rain of very light intensity composed of the less than 0.5 mm, means if it is not a rain but it is having the lesser droplet size, that is less than 0.5 mm, this is known as the uh, drizzle rain. Like it will comes and it will go. Like it is not having that much of rain. Some days you will see small rainfall will come and it will go. It is called as a shower, but Drizzle is a type of the rainfall. It will come and it will go. That size is very less than 0.5 mm of rainfall. For example, if the rainfall is the rain droplets are having the size of less than 0.5 mm, which is known as A rainfall, B drizzle, C shower, D something else. So what will be your answer? It is known as drizzle. When a rainfall is completely evaporated before reaching the soil, it is known as the mist. Like it will come to the rain, but it won't reach the ground. It will evaporate in the atmosphere itself. This type of rain is known as the mist. Mist means like it is like a spray. Just it won't reach the earth's surface because of the high temperatures and the high air temperatures. The whatever the air is rainfall is occurring, it will be evaporate into the atmosphere. So this is known as the mist. When rainfall falls on the any material and ground having the sub-freezing temperatures, is known as the glaze or freezing rain. Means in the snow, like in Shimla or in Manali or in any Himalayan places, or in the Uti and these places. So what will happen is the rain, the cool temperature, freezing temperature, rainfall will occur and it will becomes like a sheet or coating of the ice. This is known as a freezing rain or glaze. Like you can see in the if you park any vehicle in hill station, so after morning you will see like any layer will be occurs on the glass. So this is known as the freezing rain or the glaze. This is known as the freezing rain. You people have been to any hill station, you can observe this type of the rainfall. So it will be like it is not a freeze, it is not a ice condition, it's not in the freeze condition. It will be like it in fridge also we can see the glass. It will have like some ice structures. It will be occurs. But when you open the fridge for certain time, automatically in the deep freeze, when you open automatically, that will be falls as a raindrop, like droplets. So that is a freezing rain. And and if this is having occurs the very thick and frosty deposit and sub-freezing temperatures is known as the fog. In the early mornings of the winter, you can see the fog. Fog is like it will contain the air vapor pressure and it will be very way than the rain droplets. And snow is nothing but sublimation of water vapor at sub-freezing temperatures known as the snow. Like that is water vapor will be converted into the ice particles. That is snow. If the snow size will be more than 4 mm or 5 mm, it will be like hail. Like we in the summer we will see is a larger ice will be falls on the earth surface, which is known as the hailstones. So that is hailstones. So these are the different types of the rainfalls. So if it is evaporating before reaching the soil is known as the mist. And what is a freezing rain? What is a hail? What is a snow? These type of the definition should be very careful and you should know all the definition exactly because we don't know like they will ask very random questions and we will confuse in the examination. So everyone should know about this one and what is the and clouds and everything we will study in the next class. So till now we covered all weather parameters like solar radiation, temperature, and relative like humidity, wind, precipitation, almost all weather parameters like 7 parameters as I told yesterday. So we covered till now. If you're having any doubts, you can ask now. Okay, any doubts till now? If you're having any doubts, you can ask. If you're not having any doubts, you can leave the class. So thanks for your patience and listening. So you can leave the class. If you're having no doubts, you can leave the class. If you're having anyone having doubts, you can ask in chat box or you can ask in the directly.